Hello everyone, in this lesson, continuing our surds, today we are going to look at rationalizing the denominator. Now, from an irrational surd, we are going to do a rational surd, and it helps us to keep our understanding to a certain format. It becomes a messy, long decimal number to a shorter version of precise rational number. And I'm going to show you how the math behind it works. Okay, and as we proceed to the last question, you're going to see a more complex denominators where there are binomial terms or two terms in the denominator. So we're going to make use of conjugate. Okay, so we're going to talk about what is a conjugate, and then we're also going to make use of difference of squares rule in rationalizing this denominator. So let's start. But the idea behind this is, again, remember, it operates on this fundamental rule of when you have a square root and there is a square, they can cancel each other, and it can be just the number inside. Or if you have a square root number and you square it, you can cancel them and still it's going to be a number by itself. So again, I'm going to make use of this. So now what I see here in the denominator is I see a square root of 3. So in order to get rid of the square root, I'm going to multiply it with square root of 3. But remember, in our algebra solving, we never just cannot randomly bring in something that we like. It still have to make sense to the original question. But if you multiply and divide with the same thing, you haven't changed the original question. So that's the reason. Look at your denominator, and that's the number that you are going to work with. So you're going to introduce a square root number just like that, but you have to do it in the numerator and the denominator. So now watch what happens. So we have top times top, which is 3 square root 3. And in the denominator, you have square root of 3 times square root of 3. So what did I say? When you have square root of 3 times square root of 3, it would be square root of 3 squared, whole squared, and the cancel, and you'll end up as 3. Now these two can be cancelled, and the final answer is only 3. So from 3 divided by square root of 3, you ended up being just getting square root of 3. You see, it makes it more simpler. Where are the applications? There's many applications in terms of engineering, but this is like the building blocks to get there to complex numbers. So if you're ever wondering, Miss, where am I ever going to use this? Just learn the skill. Okay, that's all I would say. Here, you have to eliminate square root of 3 again. So you are going to do what? Multiply and divide with square root of 3. These are simple monomial denominators. That means you only have one term in the denominator. So this is much easier. So what would happen here? You will have 2 square root of 2 times square root of 3 divided by square root of 3 whole square. So these cancels. So in the denominator you have 3. Yeah. And then according to your surd law, square root of a times square root of b is square root of a times b, which is 6. So this is what we ended up with. This is our final answer. Same thing here. This is a monomial denominator. So I'm going to multiply and divide with square root of 5. Yeah. So that the denominator would end up as square root of 5 squared, because square root of 5 times square root of 5 is square root of 5 squared. This cancel, and you are left with only 5 in the denominator. But whereas the numerator part is a bit tricky, because there are 2 terms in the first fraction here. So you are going to do 4 minus square root of 2 times square root of 5. Yeah. Then you remember your rainbow technique or distributive law. We are going to do that. So the first one is going to be 4 square root of 5 minus square root of 2 times square root of 5. So So your final answer is going to be 4 square root of 5 minus square root of 10 divided by 5. Yep. So that's where we ended up by rationalizing the denominator. So there's no more square root in the denominator. Because if you have a surd, it is an irrational number, means it can go without a pattern. And dividing something like that would make it more complex. So in order to eliminate a complex decimal number, we are finding a way to bypass that problem. The value doesn't change. So if you have put the original question in the calculator and if you put the answer in the calculator, you end up getting the same value. But this is just another process where your goal is make the denominator look like a normal number rather than having a square root. So in this case, I'm going to multiply with square root of 15 in the numerator and denominator because square root of 15 is my focus. I don't have to worry about the two. So I can simplify this right here straight away. So this is going to be 3 square root of 10 times square root of 15 divided by square root of 15 whole square. So they get cancelled, and at the moment I'm seeing 15 in the denominator. So this is 3 square root of 150 divided by 15. Now I'm going to cancel even further because 3 goes in 15 5 times. So your final answer is 150 divided by 5. There you go. And it's good to have a box around the solution. Okay. In this case, what we are going to do is we are going to do 4x divided by square root of 2x times, so square root of 2x is going to be my multiplying numerator and denominator terms. So you will have 4x times square root of 2x in there, in the numerator, divided by 2x, because the whole squares would cancel the square roots and you would just be left with 2x. So you have x and x cancelled, you have 2 and that would be 2. So your final answer here ends up being 2 square root of 2x. That's it. Alright? Now this one is a bit tricky. You have two terms in the denominator. So before we start, I want you to understand that there is a term called conjugate, which is nothing but it is like you do the opposite of what is given. So if there is a minus in between the two terms, you do plus. So the conjugate of square root of 6 minus square root of 3 is square root of 6 plus square root of 3. So in other words, if it is a plus b, change it to a minus b. And why am I making use of that is for a specific formula. It triggers the difference of squares. So which is if you have a plus b and you multiply a minus b, you can simply write as a square minus b square. And if there are any square roots, the square would cancel and you'll just end up getting the same number like a or b. So that is the idea. So this formula is helpful because it will eliminate the square roots. Okay, so watch this here. So if focus on the denominator. So what happens to the denominator in this question? So I'm working first denominator because I have to rationalize the denominator. So I'm multiplying square root of 6 minus square root of 3 with square root of 6 plus square root of 3. Because remember, your conjugates you would have done square root of 6 plus square root of 3 in the numerator and then square root of 6 plus square root of 3 in the denominator. You're not changing the original value. Now this would end up as a square. So square root of 6 a square minus square root of 3, which is the b square. And these two would get cancelled, so you have 6 minus 3, which is 3. That's denominator, rationalized straight away. Now let's focus on the numerator. Okay, so now focus on your numerator. I'm going to change my colors so that the numbers look different for you guys to follow. So in the numerator, currently I have 2 square root of 3 plus 5 square root of 2. And the new bracket that I did is square root of 6 plus square root of 3. This is what I have. I'm multiplying. Now, if you'd have remembered your rainbow technique or distributive law, so you would have multiplied this, and then you would have done this to this and this to this. So when you have 2 square root of 3 times square root of 6, yeah, you would end up getting, watch this carefully, 2 square root of 3 times, 6 can be written as 3 times 2, which is nothing but 2 square root of 3 times square root of 3 times square root of 2. Now, these 2 square root of 3's would end up becoming 1, 3, because again, I'm making use of that square root of 3 squared. Yeah, square root of 3 squared, cancel only 3. So the final answer here would be just 3. So 3 times 2 is 6 square root of 2. That's what happened when I multiplied the first arch, first green arch. Now for the second green arch, which is 2 square root of 3 times square root of 3, it is nothing but 2 square root of 3 times 3, which is simply 3, or end up being 6. Now for the red arch, which is 5 square root of 2 times square root of 6, there's nothing much we can do, which is nothing but 12. And for the last one, 5 square root of 2 times square root of 3 is 5 times 6, square root of 6, because 2 times 3 under square root, you would have multiplied that and you would get square root of 6. Again, you need to know, I can't emphasize how quick you have to perceive your index laws. Yeah, square root of a times square root of b is nothing but square root of ab. You can multiply those two numbers. That's what I did here. And then constantly I'm making use of this identity to eliminate things. So now let's put everything together. See what's happening. So in the numerator currently I have put all the pieces together now. So you have 6 square root of 2 plus 6 plus 5 square root of 12 plus 5 square root of 6. Yeah. And in the denominator, we ended up having what? The entire denominator ended up being 3. So your final answer can be written as 6 square root of 2 plus 6 plus 5 square root of 12 plus 5 square root of 6 divided by 3. So that entire problem has now been rationalized to this. I'm not looking for any more common factors and things like that, but it's simply written like this. All right. Thanks again. Thanks for listening and paying attention throughout the video. I know this was a long video, a lot of concepts and tricks that you need to perceive in solving this, but watch the video again and you will understand everything that I have been doing. So that's it, guys. That's all from my side, and have a wonderful, blessed day. Bye.